afternoon, evening, wherever you're joining us from. Thank you so much for coming for this webinar. Your presenter today is Sergio, who's joining us live from Spain. Sergio is a core member of the Grails and Micronaut team here at Object Computing, and today he's going to demonstrate the multi-tenancy capabilities that have been built into Micronaut. We are recording this session, and we'll plan to send out the recording to all the participants today shortly. So with that, Sergio, I will turn it over to you.
Thank you, Jen. So welcome, everyone. Welcome to Micronaut multi-tenancy webinar. The plan is to cover the multi-tenancy capabilities that are built into the framework and also cover the integration with GORM, which is a data access layer, which was originally used in the Grails framework and that can be used outside of the Grails framework, and we will show it today being used in a Micronaut application. We're going to showcase some of the multi-services oriented features of the multi-tenancy capabilities, such as token propagation. I don't have a lot of slides. I have a demo of which I want to go over with you so that you can show what it's involved in converting a Micronaut app into a multi-tenancy aware application. And hopefully you can take those ideas and put them into practice. As Jen said, I am based in Spain. I'm based actually in Guadalajara, which is a small city close to Madrid in the center of Spain. Where we are enjoying the summer right now. I write a weekly newsletter called GroovyCalamari.com. If you are into Micronaut, Grails or Gradle or Ruby-related technologies, you may find that newsletter interesting because it covers such topics. I started a podcast as well in podcast.groovycalamari.com, and I am organizing the Gridge conference, which is conference about same topics: Micronaut, Grails, Groovy technology, Groovy technologies, Spock, Gradle, etc. In Madrid in spring. If you are planning your 2020 conference, we don't have dates yet, but stay tuned. And you can find me on Twitter or on my personal blog. And you will find a link to my email address at the end of the presentation as well. Multi-tenancy, as it relates to software development, is when a single instance of an application is used to serve multiple clients tenant in a way that each tenant data is isolated from the other. Multi-tenancy is a feature that excites me a lot in frameworks because at the end of the day, what we do is we build applications and we build software products, and multi-tenancy in the incarnation of software as a service allow us to build sustainable applications, allow us to build businesses around the software that we build, and that's something that I am really interested in. You probably are using many multi-tenancy applications in your day-to-day life, and hopefully you will get inspired with this webinar, and the next software as a service product that you build will be built with Micronaut and will be a multi-tenant application. So the steps to get a multi-tenancy module installed is really straightforward. It's just you will need to add one dependency in your build.gradle file. If you are using Gradle, which I will be using through my examples, really similar configuration. If you are using Maven, so Micronaut is build agnostic, so you can use either Gradle or Maven, and similar configuration is required. What importing the Micronaut multi-tenancy dependency will do for you in your applications will import several classes and via configuration you will be able to turn on several beans, which will allow you to resolve a tenant ID. One of the important concepts in multi-tenancy is you need a way to resolve the tenant that is being used. I normally like to think of tenant as client, but tenant can be multiple things. So you can have like a newspaper which uses a multi-tenancy approach to display different news depending on the region of the person visiting the newspaper. So yeah, you will be using tenant through this presentation, but if you are confused, think of tenants as client set of data, and that will probably be easier to wrap your head around. Micronaut ship with the following built-in tenant resolvers. We ship with the cookie tenant resolvers, which allows you to resolve the current tenant from an HTTP cookie. The name of the HTTP cookie is by default, I believe, tenant ID, but that's configurable. So if you need a different cookie, that's completely possible. We have as well a really common one, which is the HTTP header tenant resolver. And the same as with the cookie, in this one, we will resolve the value of the tenant from the value of an HTTP header. By default, I believe is tenant ID, but you can as well configure the HTTP header name being used. Principal tenant resolver. This will be used, will resolve the current tenant from the username of the authenticated user. So if you, for example, want to basically, whenever a user logs in, you want to display different data, you may want to use this tenant resolver. His name is principal because the JavaX security principal class, which is a class that you can inject in your controllers. So that's where the name comes from. Then you have the subdomain tenant resolver. This is one that, although you probably don't use initially when you are like testing the waters of the Micronaut multi-tenancy support, this is probably one of the most used on the wild. So the idea is that depending on the subdomain of your application, a tenant will be resolved. I will show you a couple of examples now where that's being used. And then we have another one called the session tenant resolver, which as well resolves the value from a value in a session entry. The session entry name is as well configurable, and I believe by default is, as you may imagine right now, a tenant ID. I was telling you that basically dividing using a subdomain to split the client data is really common on the wild. For example, this is a screen capture of harvestapp.com, which is a time tracking application, which when you register, it asks you for a URL slug, which will be used to basically create a subdomain for you. And whenever you sign in, you are basically in your subdomain and the data is from your account. And the same, for example, this is a screenshot of Highrise, which is a software as a service product of the previously known as 37 Signals company. Now they are named Basecamp, but this was a CRM application that they used to have. Yeah, same as with Harvest. When you registered, you basically claim a subdomain, and that will be basically your home, and they will be using that to basically resolve the data that they need to pull through. A couple of other tenant resolvers that are built into the framework and that are really useful for testing are the system property tenant resolver and the fixed tenant resolver. We will see an example using the fixed tenant resolver. These two are really useful in testing. Fixed tenant resolver is one tenant resolver that you can use in production as well. For example, if you know that you are going to support multi-tenancy, but for right now, you just don't want users, or you just don't have implemented the ability to change the tenants, you can just start by fixing the tenant resolver and just having all your code ready that when you roll out the feature to change tenant resolvers, you don't need to change like your persistent layer or anything like that. So another interesting concept is the concept of tenant propagation. I'm going to try to show all these concepts with a demo. but I wanted to show it first with an image that I believe explains well the app we will be using. Here I am. If you are able to see the bottom of the screen, it says there are two requests, one in green, one in blue. The one in green is targeted to Sherlock.micronaut.example, and the one in green is targeted to Watson.micronaut.example. The idea is that the gateway, in this case, will use a subdomain tenant resolver to basically understand that the tenant the resolved tenant identifier of the blue URL is Sherlock, and the resolved tenant identifier of the green URL is Watson. Typically, in a Micronaut applications, you will have multiple services, and they will communicate with each other with HTTP clients. And HTTP clients typically are identified with a service identifier. Here, imagine in this example, you have a gateway application, and then this gateway application communicates with a catalog, which is another Micronaut app, which wants the tenant ID to be sent via an HTTP header, because it will resolve the tenant ID using an HTTP header tenant resolver. And what the micro tenant propagation feature will do is this will be completely transparent to you. You will get a tenant as a subdomain, and subsequent requests to other services in your network will contain the tenant ID HTTP header with the value originally received from the subdomain without you not doing any work to support that. You will not need to add the tenant ID in your HTTP header. You will not need to do anything like that. I'm gonna do a demo and illustrate all of this, but this is the idea. This will make your code really simple, because it will take care of resolving the tenant and propagating the tenant through your microservices network, and this can be really powerful. In order to support such a setup as the one I was describing, in the catalog one, which is the second service here in the top, this one here is using an HTTP header tenant resolver, right? It's resolving the value from the tenant ID HTTP header. And because of that, you will need to turn on the HTTP header tenant resolver. The way you do that is with the property Micronaut.multitenancy.tenantresolver.http header.enabled. You set that flag to true, and automatically you have a bin of type tenant resolver, which is HTTP header tenant resolver class. In the other service, however, you have a more complex setup, because on the one hand, you resolve the tenant from the subdomain. In order to do that, we have set up here Micronaut multi-tenancy tenant resolver subdomain. But then you want to write the tenant which got resolved. You want to write that header down through other calls in your network, and that way you have to turn on the tenant writer. So you have to turn on the tenant writer, and we are using, you are writing the tenant into an HTTP header, and that matches our diagram, because we want the tenant to be written to an HTTP header. So we enable the tenant writer HTTP header, and sometimes you may want to restrict how are you propagating the tenant. So you can say, I want to propagate only to these services. So here we only have one service. So this will be a regular expression where you could have multiple services in your network, and you say, I want to propagate the tenant resolver to all these services. Or you can also use a URL pattern, I believe. So with this in mind, I'm going to show you this with a demo, which I believe will make for easier understanding. So let me go out of my presentation and let me show you the first service. So instead of setting up subdomain tenant resolution, I have here an app which uses a cookie tenant resolution. So let me show you the app. I'm going to try to make the font as big as possible. We have a chat window and a question and answer windows. If you have any questions, please use the question and answer window, because that allows us to flag questions as answered or dismissed or follow up. If you have a more general question, try to write it in the chat window. I have this open here on another monitor, so I will try to keep an eye on those. Let me make my font bigger first. If anyone has any problems in the phone, let me know. I don't think so, but so we have an application class, nothing fancy. This is a Java Micronaut application. The same concepts will apply if you are using a Kotlin or a Groovy application. I am not doing anything special here that will get you confused, and I am pretty sure that all of you will be able to follow with the Java application. We have a home controller. So the home controller is listening in the root path. When you have the root path, you don't need to specify the qualifier. So I leave that blank. I am using the Micronaut views support. So I am rendering actually an HTML page. So in order to do that, I have here included the views dependency, and you need to tell Micronaut which views technology are you using. Here in this demo application, I am using handlebars. We have support for FreeMaker, TimeLeaf, velocity. So nothing in particular why I use handlebars, just because I can, basically. When you use the views module, you can specify the views that you want to render, right? So here I am specifying the home. I'm basically here, as you can see, this is a simple HTML page where I am rendering a title, and I am looping through a list of books, and I am rendering the title of the book. And here in the bottom, I have a link to another URL called TENANT, which we will see shortly, which is basically another controller, which will allow me to change the tenant. Here I have a book fetcher, which if I click into it, you will see it's an interface. It's not even a declarative HTTP client. And this is typically the way I will do it is I will have an interface, and then I will have an HTTP client, which extends the interface and just override the method and adds the mapping to the method that you are overriding. So here I am doing a request to that /books, and this will return a list of books. This will be a non-blocking call because I am doing an HTTP client request. And here what I have is probably the easiest way to tell which URL you are using is I am not using anything like service discovery. I am just telling here Micronaut that for the identifier books, so these books matches the identifier right here. So for the books identifier, the URLs, this can be a list, or we actually have you can specify only a single one. If you have like multiple instances, you can specify a list. So I'm specifying here localhost 8081. I specify here, to be clear, localhost 8080, and by default, Micronaut will start when you run the app in 8080. And here I have the settings that I was discussing with you before. So I have propagation enabled, tenant resolver with cookie enabled, and tenant writer. Johnny asked in the chat if Grace has similar tenant writer setup. No, I don't think Grace has any tenant propagation capabilities. GORM has really cool multi-tenancy features, but not particularly any one designed for microservices. So this will probably be one that is useful. Let me show you the tenant resolver now, the tenant controller, sorry. One thing that we have before I show you the tenant controller is I have the homepage filter. Basically, this is a filter that will intercept calls directed to the root of my application, so calls directed to home controller. And what I do is I inject, I'm using here constructor injection. I am injecting the tenant resolver bin, and I am calling resolve identifier, and this may throw a tenant not found exception. If that's the case, I assume that the tenant has not been selected, and I forward to the tenant controller. So that the idea is if you are not ready, when you go to home controller, you will be redirected to a tenant controller. This C other is basically a 303 redirect. So here in the tenant controller, I am rendering another view. I am rendering the tenants view, which, as you see here, it creates an unordered list of tenants, and it basically uses it's a really simple setup when I have a URL, which uses a path variable. And when I click the URL, this other endpoint is called, right? So selecting a tenant for us in this particular example means creating a cookie, right? So we are creating a cookie, and we are using the cookie name, the value used by the cookie tenant resolver configuration. So there is a really similar setup. So if you are using, we are using a cookie tenant resolver, there is always a cookie tenant resolver configuration. If you are using HTTP header tenant resolver, there is an HTTP header tenant resolver configuration. So you can use that bin to make sure that you are actually using the cookie that the tenant resolver expects, the cookie name. So I am setting the cookie and I am putting as a value the path variable that goes into this controller URL, and that will basically change the value of the tenant. So in order to run this app, I will show you the test later, but I want to show you the app running. So in order to run this app, I need to show you the other application. I need to show you the books application. So just to sum up, this application has only three endpoints, basically. The home endpoint will render books. In order to fetch the books, it fetches the books via the network, right? And what we are doing here is we will be able only to visit this page only if the tenant resolution has been resolved, right? So what the tenant propagation does for you is, if I didn't have tenant propagation in my project, I will need to have something like tenant resolver here. I will have to have something like here, like before calling the endpoint, I will need to do like tenant resolve tenant identifier. I will need to have like resolve the tenant identifier and then add a method to the, I will need to add here an add header, a string tenant ID, right? So I need to add something like that, and I will basically need to, here I just have one endpoint, but imagine if when you have multiple endpoints that need to be all multi-tenancy aware, this can get really in your way, right? So in order for this to work, I will need to have the constructor, etc., right? So the idea of tenant propagation is that you don't have to care about all this code. Micronaut will do this code for you. So you don't need to like add a header parameter to your method, resolve the tenant before calling other microservices in your network that are tenant aware. That's basically the beauty of tenant propagation. So for the other service, I have created several examples. The first one that I'm going to show you is I'm going to use Micronaut data. For those who are not aware of Micronaut data, Micronaut data was recently announced and is a project which will be similar to GORM. For those of you who are familiar with GORM, it's not as feature complete as GORM, but it has really interesting compile time repository implementation capabilities, also similar to things like Sprint data. So basically, it will compute repositories for you on compile time. And let me show you actually what I mean by that. I have here a project called Books Data. It uses Micronaut data JDBC, this sample app that I have. In order to use that, I have these dependencies. So we have currently one milestone of Micronaut data. I encourage you to test it because it's really cool. You will need to have that I am using an in-memory database. You could use MySQL, Postgres, whatever database you need. So and this is like the connection pool dependency. So depending of this will depend of your configuration. But as you see, it's a pretty simple setup. Then I have one database called which I define in my application.yaml file. I have an in-memory database which will be basically dropped when I stop the application, and it will be created, the schema of the application will be created automatically when I start the app. I am using, again, an in-memory database just for the sake of having this application simple, but you could use a MySQL, Postgres, or anything like that. There is no limit on that. I am listening on port 8081. So one app will be listening on port 8080 and the other one will be listening on port 8081 on my computer. And in the other one, I was resolving the tenant from the cookie. Here I am on resolving the tenant from the HTTP header. And you are probably aware that I am not enabling, since this service is not communicating to other services, I didn't turn on tenant propagation or anything like that. So there is no tenant propagation, there is no tenant writer or anything like that. The app is really simple. I have one entity called book, which has, I am using what's currently normally called as discriminator tenant mode, which basically means is I am splitting the data in my database using a column. So I have my book class, which at the end of the day will be mapped to a database table. And one of the columns of the database is my tenant ID. And this will be an auto-generated value for me. And here I'm designated this constructor as creator. And let me show you what I mean by basically repositories implemented by me at compile time. I have this repository called book tenant aware repository, which extends from CRUD repository. And what I pass here as parameters is the entity that I am using and the primary key type that I am using. And this gives for me already a safe, so I have a safe method, a safe all, etc. So you will see that I am using the safe method already. And I can use this kind of easy to read methods that are implemented by me for the framework. So I am writing here find all by tenant ID. This micronaut will realize this is a read operation, so we will use the proper transaction demarcation. So it will basically treat this as this is a read-only transaction. And basically it will return me a list of books here. And I have here as well a book repository. This is a regular bin, which is implemented with at Singleton. And the idea of this bin is to abstract the user from the actual tenant. So the tenant resolution is being done in this service. And I have a method called save and a method called find all. But if you see, there is no tenant ID parameter. That's basically resolved with this private method, which is resolving the tenant. So the idea is that I will inject this repository in my business logic. In my case, I am injecting this in the controller. And this will talk with the tenant aware repository, which is the one implemented by Micronaut data. So if you go to book controller, again, I am using construction injection. This is listening in the slash books. If you remember from the HTTP client that we were using, this was listening also in the slash books. So this is consuming the endpoint exposed by the controller. And we are returning a list of books. Micronaut by default returns application JSON. So no need to specify the media type. By default, Micronaut assumes you produce and consume JSON. And this will basically render a book as a JSON file. I am just rendering directly the mapped entity, which is automatically also, I believe, annotated as introspected. And the other part that I have is I have a bootstrap class. Bootstrap, for those coming from Grails, the idea is similar as we have in Grails, a bootstrap.groovy. I have a class which implements application event listener, server startup event. So basically this class will be called when the application has started. So when the application has started, I am persisting books. And what I am doing is I am injecting the book tenant aware service. And I am persisting some books for Sherlock Holmes and some books for Moriarty. So I'm persisting actually 10 books for Sherlock and 1 book for Moriarty. So the idea is when you call the book controller and you specify a tenant ID, this book repository will in turn call the book aware tenant repository, which will need this tenant ID, and in turn will do the appropriate query to the database and will return me only the list of books that I have. I have a test showing this thing. And this test shows some of the nice features of using Micronaut multi-tenancy capabilities. So this is a setup that I use often, which is I have a class called, I am using Spock to test here. And I am using traits a lot because I believe in tests, traits gives you a lot of flexibility. So I have one trait called configuration fixture, which exposes an empty map. And this get configuration method, this trait is similar for those who are not coming from, don't know what traits are. Traits are similar to default methods in Java 8 and above in interfaces where you can have implementation traits, can have more things. So basically, you implement a trait as you implement an interface. And what I'm doing in the abstract class embedded server specification here, I am starting a server. I am using the configuration from the trait, which can be overridden in the test. And then I have some utility here methods. For example, I have one client, which is a blocking HTTP client. Typically in your test, you will want a blocking HTTP client. So that's what I am doing. That way in my test, I can do something like this. I can call client, and this is calling the client from the embedded server specification, which is a blocking HTTP client, and I'm calling retrieve. So basically, Micronaut HTTP clients typically have two methods that you will be interacting with. You have either retrieve, when you care only about the return type, and exchange, when you care not only about the return type, but also about the wrapper, about the HTTP response, when you want to, for example, check a particular HTTP response status code is there, or a particular header in the HTTP response is there. Another thing that this test highlight is how easy it is to basically map a list of POJOs in an HTTP response. If you have used something like Mozi or similar like that, that's more complicated if you are using that approach. So here for this particular test, I am disabling HTTP header resolution, and I am instead using a fixed HTTP header. And I told you before that you can configure which of the value of the fixed tenant resolution is. And in this case, I am setting this value to be Moriarty. So when I do the request to the books controller, this test, this is like asynchronous because the bootstrap class needs to execute. So I am using these polling conditions. This is a Spock construct, which allows me to take for asynchronous condition. And I am telling that eventually the number of books that I get is only 1. And for Sherlock, I have the same one, where I am testing that the number of books that I get is only 10 books, right? So if I start my app, if I start both apps, so let me just start first the books data. This should start import 81. Starting import 81. Let me start now the gateway. That will start import 8080. Let me open Firefox, for example, or whatever browser you want. So I got redirected automatically to tenant because I don't have any cookie. Actually, I have a lot of cookies, but let me remove these cookies from other stuff. And let me show you that again. If I go to the root, I am automatically forward to tenant. If I select a user such as Sherlock, I have a cookie called tenant ID, and the value is Sherlock. And this is automatically used by Micronaut to resolve in the gateway the tenant resolver, the tenant. And it basically takes that value and propagates in the network calls without me doing anything. You see, I don't have tenant ID logic here at all. It's propagating that for me, and that's being used in the other microservice using HTTP tenant resolution, HTTP header tenant resolution, and it's returning only my list of books. So if I want to change my tenant, I can come here, select Moriarty, the cookie value changes, and I am getting only my list of values. So really powerful. Tenant propagation is one of the features that I am more pleased with regarding multi-tenancy Micronaut, because it's really removes a lot of code from our code bases, and that's always a good goal to have. And I'm gonna talk a little bit about GORM multi-tenancy. So for those who are not familiar with GORM, let me actually show you. So the home of GORM is GORM. So that will be https gorm.grace.org. So this is the home of GORM. GORM is a really powerful data access tool. If you are not aware of GORM, it's really wonderful. It's probably one of the big reasons why the Grails framework has been so successfully through the years, because it basically GORM abstract you from, as you see, there is originally GORM was GORM for Hibernate, but with time there is GORM for MongoDB, there is GORM for there is support for GraphQL, there is GORM for Neo4j. So GORM is not just for relational databases, but it's also for we like to say it's a data access toolkit. So if you want to search for the multi-tenancy documentation, you can find it here, right there. It's linked in the slides. You will get a copy of the slides. Basically, there are several steps to use GORM in a Micronaut application. First of all is which kind of multi-tenancy mode you want to support. GORM supports by default 3 modes. Which we will see later, database, schema, and discriminator. The next step you need to do is tell GORM which tenant resolver are you going to use. You will see that the tenant resolvers that GORM ships with are almost identical to the ones that I saw you in Micronaut. Indeed, we created a bridge classes so that you don't have to write the tenant resolvers that you may be already using in a Grails plus GORM application. And we have equivalents for those. Next step will be you have domain classes. So the way you map your entities in GORM, normally we call those classes domain classes. You have to tell which classes are going to be multi-tenant aware. And if you are using a multi-tenancy mode such as discriminator, you may need to specify which column are you going to use as your tenant ID discriminator column. And then one of the nicest features about GORM multi-tenancy integration is that GORM has really nice transformations and methods to simplify the code. You saw now that for Micronaut data and multi-tenancy, I was using a books repository and a books tenant-aware repository. You will see that that's not necessary if you are using GORM, because GORM will take care of that. These are the 3 multi-tenancy modes that GORM support. So we support database, we support schema, and we support discriminator. I'm going to show you an example of database and discriminator from an isolation point of view, which is something that you probably want to achieve, right? So the idea is that you don't want to show one client the data belonging to a different client. So from more isolation to less isolation, database will be, of course, more isolation, then schema, and then discriminator. With discriminator, you can have a perfectly well-functional application. You just have to be extra careful, because at the end of the day, you are like sending queries to the same database for all your clients. So that's always more risky to show data to one client to other client. So you will need to use this is example of the configuration that you will require to use GORM and multi-tenancy in a Micronaut app. So you will need to select, here I'm selecting database mode, and I am specifying the tenant resolver class. So when I was using just pure Micronaut tenant resolution, I was not specifying like the class itself. I was just saying like this particular bean, enable this bean or not. Here you have to specify the class. These classes are already written by us. You can, of course, create your own class and extend from tenant resolver, the tenant resolver coming from GORM. You can do that, but yeah, you have several built-in options that probably will suffice you most of the times. Here, for this example, I'm going to use the HTTP header tenant resolver. The next step is you have to tell, when you map your domain class, you have to tell that this is tenant aware. So you do that with the multi-tenant. You have to implement multi-tenant. in your domain class. And if you are using like a discriminator column, you can use either the default tenant ID or you can specify here I'm specifying that the publisher column is going to be used as the tenant ID. So if you are using a column which doesn't match the name tenant ID, you can specify that. Then you have several annotations at your disposal, which will make your life easier, and we'll see that how they do make our life easier working with the same example. The @current tenant is particularly useful when you use GORM data services. GORM data services are compile time implemented services similar to Micronaut data automatically compiled repositories. That's the same concept. So the idea is we will see that you can have a service annotated with that current tenant, and all the methods in that service will use the right tenant for you without you doing anything. Then you can have use the annotation @tenant, where you can use a qualifier specifying which tenant ID you want to use. Or if you have, for example, a GORM data service which you have annotated with that current tenant as a class level, but you have methods in that particular GORM data service which you don't want to be tenant aware, you can specify the out without tenant annotation. This will be an example of a possible GORM data service. So you have here, this is not a GORM data service, this is just a regular service, but this is annotated with a current tenant. And then you have some methods annotated with without tenant. You have some methods annotated with @tenant. So different options at your disposal with transformations, which will make your life much easier. I want to show you the same demo, but with GORM. So let me try to do that. And then I will try to answer the questions that I saw pending in the chat. So let me open, I just stop Gateway. Let me move Gateway to the other monitor. Let me stop the Micronaut data application. Let me open here in desktop books with GORM discriminator. So a couple of things to use GORM in your Micronaut app. If you want to use the multi-tenancy capabilities of GORM, you can include the Micronaut multi-tenancy GORM. This will give you several classes that you can use as tenant resolvers. Then I am including here the Micronaut Hibernate GORM. This will simplify the GORM configuration for me. And then I have to pull the GORM dependencies, database dependencies, JDBC, etc. So with all these lines, you have all that you need to use multi-tenancy and GORM for your persistent layer. So I think it will be a pretty common pattern to see applications which combine microservices written in Groovy using GORM and Micronaut and microservices written in Java for stuff that don't use GORM, and other written in Kotlin. I can see that as a pattern in the future. So here I have all Groovy code, really similar to Java. If you are coming from Java, you will probably miss semicolons, public modifiers, default in Groovy. This is our domain class. You annotate this as with identity. If you want this to be multi-tenant, you have to implement the multi-tenant interface. This is helps the IDE. This is mostly syntactic sugar. And here, just to be clear, I'm specifying that the tenant, even this will be optional because this will be the default. I am just saying that this column is used as the tenant ID. Here in the book controller is identical to the other one. The book controller. Only the public modifiers are missing because they are the default in Groovy. And what you will see is that I don't need a book tenant aware repository. I just have a book repository, which is an interface with two methods, save and find all, the same methods that our book repository had in the Micronaut data example. But this is just in an interface. We don't need to have like a different service. Here, this annotation @service tell GORM that this is a GORM data service that uses the book domain class, and the @current tenant annotation, that's the magic of taking care of using the proper tenant resolved class for me. In Bootstrap, I can save I can call the book repository. You saw that the book repository doesn't have a tenant ID parameter, but you can use this static class method called tenants with ID, or you can specify the ID. And this is a closure. This is similar to a Lambda in Java, where you can execute a block of code, and this block of code will use the tenant ID specified here. What else? In configuration, you have to tell via configuration grace GORM multi-tenancy mode. I'm using discriminator mode, and I am using the HTTP header tenant resolver. That's a class coming from the Micronaut multi-tenancy GORM dependency. So with all that in place, you can just run the books run up, and this is exactly for the gateway use will be transparent. It will be the same. We just have swapped one implementation with the other one, but nothing has changed. So I'm starting the gateway as well. And I can change tenants and use GORM on the background. So as you see, GORM is like it has some extra capabilities for multi-tenancy out of the box, which currently Micronaut data doesn't have. I'm going to try to show you pretty quick how a configuration with multiple database will look like before I go to the questions, because we have 10 minutes. So let me show you same app, but instead of using a column to discriminate our data, we are using different databases. So I have here books application. Here in my book domain class, which is the one that is mapped to a database table. I don't know what this is showing in red. I don't know if I need to refresh this thing, but important thing is I don't have tenant ID here anymore. So no tenant ID column. Book repository is exactly the same for me. I don't have to change anything there. Just in application YAML, I'm telling that I am using, instead of discriminator, I'm using database mode. And I have two databases, and the name of the not the name of the database is actually in the URL, but the way I refer to them in configuration matches the tenant ID that I will get. So when I get tenant ID Sherlock, I will go to the Sherlock database reference here. And when I get tenant ID Moriarty, I will go to the database reference here. So as you see, really similar to swap between database mode to discriminator mode.
Thank you again, Sergio, and everyone today for attending. And we hope that you will join us for our next webinar we have coming up later this month with Paul King to talk about Groovy. And we look forward to hearing more about Micronaut from the rest of the team later on. Thank you.
Yeah, thank you everyone for joining.